Hello viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about carbon nanofluorescent or NCF. So let's dive deep into it. Now, I'm talking about specifically from the fact that I had the luxury to meet the people who are working behind it and see the product video linked down below. So let's dive deep into it. So why exactly do we need something like a nanotechnology for solar? Well, reality is sun gives us a lot of energy, like bonkersly large amount of energy. To give you some mathematical context, 1.3 kilowatt per square meter, meaning if humanity can harness even a percentage of it, few percentage of it, yeah, problem solved, done, go home, sweet dreams. So in terms of power, that's not an issue. Problem is we do not know how to cost effectively harness it, meaning we have tools to harness, but they are very expensive. If we can find a tool that allows us to harness it cost effectively, it will solve a lot of problem. If we can harness all of it, all problems solved. But if we can harness enough of it cost effectively, it will solve a few major challenges. First, heating. Believe it or not, many people live in a place where they do require heating. Again, it's a very foreign concept for an Indian, but it is something that is required, bonkers amount of energy just for residential heating. Then you have cooling. Again, I do understand this part, and I have a feeling that as planet gets warmer and warmer, more and more of us will need cooling. Then you have H2O purification. Not every community is that is dealing with dirty water is dealing with industrially contaminated water. Many times they have water which is fresh water, but it is biologically contaminated. They do not have RO there, they do not have ultraviolet there. So many times they use this like this, where they just put it in the roof and for morning to evening and hope enough ultraviolet gets through it, enough heating happens that it does become a biologically sterile. Better than doing nothing. So sun has more than enough power. Sun can solve a lot of problems. It's just that we do not know how to cost effectively harness it. For example, our tools are very costly and very fragile. For example, evacuated tubes. Now these puppies are good and they can reach 80 degrees Celsius or even more than that, but they are very fragile. Hailstorm destroyed, monkey rounds destroyed. Yeah, monkey is an issue in India. So you have to understand these are fragile puppies. Then you have flat panels, again bit more robust than this, but still glass panels that crack because it has a void space. It's not a glass panel of solar panel. So very fragile and expensive. So, and solar cooking, that's why like we have tools to harness it, but they are not cost effective and they are fragile too. So not only you have to be rich enough to afford them, you have to be rich enough to replace them again. So that's why there is a serious need for a technology that allows to do all of this for cheap. So let's dive deep into carbon nanofluorescent. Basically, this nanostructure, a hard carbon fluorescent. Now, the reason why it has fluorescent is simply because it looks like a flower under electron microscope, and this was pioneered and produced by IIT Bombay. So you may have paid attention to the fact that all the paperwork came out very recently, 6 months ago, sort of say, and I was directly talking to the people who are doing it. I feel very, very lucky. So what's the whole deal here? Well, the deal is it's almost like how you have carbon nanotubes. It's same. You are growing carbon in a specific structure. Now, benefit of this is it's more like a molecule. Now, the reason why we are going through all this trouble, be mindful, carbon nanotube also makes an ultra black material known as Venta black. But problem is that puppy is toxic to human. This is not. So this structure, and it's super easy to make. So you know the joke about carbon nanotube. Carbon nanotube can do everything except leave the lab. So this is not like that. This, like, they came up with the paper, they actually started making the powder in bulk, and now they are working on scaling it up. So much more simple. And why go through all this trouble to grow carbon in this exact specific pattern? Well, this has great photon thermalization, great photon thermalization, meaning if a photon falls into it, it disappears, meaning that photon will be converted into thermal energy. Few bounce again, it will not bounce away. So it's almost, from a photon's point of view, it's a trap. It's a light trap. Light will fall into it, it will not bounce back, and it will convert it into thermal energy very effectively. And broad spectrum, let that be very clear, broad spectrum. It can absorb way too much of infrared, way too much of ultraviolet and optical spectrum. So it's like, in terms of how much it can eat from the sunlight, the answer is yes. It's like, yes, it's sunlight, it eats it. So it has great photon thermalization. Again, many things do, but it also has another aspect, that is its low phonon thermal conductivity, meaning it will not dump the energy. Many things that absorb energy very well, it's also very good at dumping it. For example, if you take a radiator that is pure black, it's very good at dumping heat, but it's also very good at absorbing heat. It is completely two contradictory fission. One is like, I'm going to eat it. Another is, I'm not going to let it out. So it allows the temperature to rise exponentially faster, meaning without vacuum chamber, it can still cross 100 degrees Celsius. So it is genuinely unique material. Basically, you have two properties. It's almost like how you have sky cool panel, it's invert of it. So this puppy eats everything and does not let anything go. So that's why we are so focused on this. And this means the solar thermal conversion efficiency is at around 87%. Now, if you are not familiar with solar industry, you may think this number does not sound 100%. Well, from any other point of view, this is like at least 10% to 20% better. So it's significantly better. And the bigger the surface area that you are talking about, let's say you are talking about 1 meter square, not that big of a difference. 10 meters square, yeah, big difference. 100 meters square, huge difference. So it is there, and it also allows you to achieve high temperature without vacuums. You do not need to worry about it, because again, that fact, low phonon thermal conductivity, it does not let the energy go away. So it will eat it up, it will not let it go away. So it allows very high temperature, and in some without evacuated tube, you can still cross 100 degrees Celsius. Of course, it depends on the load. If you put way too much water through it, of course, it will cool down, but it can be achieved. So it does not have that temperature limitation of the other systems. And it has no health risk, because this was actually used as an actual product with actual humans, and army scientists have also looked through it. I will talk more about that in future. This is, as far as we know, it's not harmful, because again, from a structural point of view, our lungs can take care of this. It's not a jagged structure like carbon nanotube or asbestos. So from a structural point of view, this is human safe. Again, more testing would be needed, but preliminary testing is like, this is safe. And again, it has been used around humans, so it's not like we are just making it up. It's like, yeah, done, sorted. So no health risk, and it's very easy to make and scale up, because the people who are working in IIT Mumbai, they started to work on it, and they're like, okay, let's scale it up. They scaled it up, and then they're like, okay, let's scale it up. It keeps scaling up. It's completely opposite to carbon nanotube, where it's like, yeah, we can't really make long strings of it. This is like, bro, we got this. We got this. It's just they are figuring out how to make it cheaply. It's not like, how do we scale it up? So that part is sorted. That's why it's moving so fast, even though original papers started coming out very, not even a year ago. So this is carbon nanofluorescents. So what products that we are talking about? So at this booth, they had few products. Ushma they had there. So they are working with Indian Army now, because they have not built a website yet. Yes, that's how early I am this time. So Indian Army, especially in the mountainous region, India-China border, they have a bunker. They have electricity there, but they need a way to heat that puppy up very quickly. Meaning these bunkers can be abandoned few times. So they want a system where there's like, just go, turn on a switch and have heated air. Problem is that if you have a resistive heating, it oxidizes the air. It smells very bad. You do not want that. So Army wanted something that was fast-acting shelter heater. Their requirement was, again, energy cannot be created or destroyed. So if you put 1 kilowatt of electrical energy, that's all you're gonna get, 1 kilowatt. But you want it to be coupled efficiently. So what they did, they delivered a IR lamp, again, so no oxidation risk, and it was covered in a pipe that was of copper, and that copper was covered with this NCF material. Now benefit is that copper increases the surface area exponentially, and IR dumps all its energy, photon energy, directly into the coating dumps that energy into copper dumps it into the air. It was so quick that everybody was amazed how effectively it worked, and Army was very happy with it. They are placing order for, like, the time when I was actually seeing the prototype, that was the third iteration. They were getting iterations after iteration. It was working that effectively, and more orders have been placed. So it works. It's a very quick. Let that be very clear. It's not magically changing your problem. If you had a normal IR lamp, it will first heat up the walls. Wall will slowly radiate it upwards, meaning you could be waiting 1 hour or 2 hours or maybe even 3 hours just before you start to feel, okay, I'm not freezing anymore. So they wanted something that is like hot air, and without the consequences of directly having hot air coming from resistive heaters. They make smell very bad, and you're talking about an enclosed space. Not good. So this was made, delivered, done. Everybody's happy, everybody's good. Then they have another system. They have 3 tools, but one tool I'm happy. Another tool, solar thermal water disinfector. This is amazing. I'm not that impressed with this. This is like awesome. Somebody had a very niche case. They've solved it, but this is awesome. This is like saves like significant percentage of human population. That's how huge this is. Solar thermal water disinfection, because many places have water, fresh water. They have ponds, they have wells, they have stuff that is not contaminated from, like, industrial pollutant, but it is biologically contaminated. So if you drink it, unless you have really, really robust immune system, you're gonna have a bad time, like a really bad time, like cholera kind of bad time. and even worse than that. So fundamentally, many rural community around the world, let that be very clear, this is not a specific thing, around the world, India, Africa, America, other places also. This is not something that is like, we just solved problem. No, you have to spend boatload of money. If you can reduce that, that is significant. This is how significant that World Health Organization have milestone this puppy. Is like, if we can solve this, lot of problems will be solved. So basically, we need to boil the water without burning wood or without burning cow dung. We need to boil the water to very high temperature, so where it becomes biologically sterile and becomes safe to drink. So great for biocontaminated fresh water. It's not gonna be designed. It's not a solar stilt. Can that be designed? Yes, that can also be built. But this time they were focusing on having aluminum cone basically, and they made a tube, coated it, and then they deployed it in field. So they put a pond water, that is this pond water, very lethal for you, and then they sterilize it using sunlight. And the solar panel that you see is just there to run the pump. So from an energy point of view, the bigger you make it, the less you need. And at some designs, I'm pretty sure you can find a way where thermal energy itself is siphoning the pump. So they got the safe water. Basically, if your water source fair, this is a very solid way of making sure that biocontaminants do not destroy you. Bacteria and viruses do not like 90 degrees Celsius water. That's how hot it got. And this is this big. So as you can see, they tested all the biological cultures of it and how much time it took. It was good. So this is a really useful tool for that. Like that heater part, that's like more of like them luckily finding like the exact requirement that they are sorting exactly right. This is saving the whole planet, and this is basically both of them are helping them getting fundings so they can go really big. This is like a starting. This is Mark 1 products. So they have it. That's why I said this is not like carbon nanotube where it's like, oh great, it's like, but it just never comes out to real life. It's like best we can have is like few nanometers long threads, not nanometer if I'm not mistaken. Somebody did made 1 millimeter or something like that, but it's not like threads. We cannot just buy threads of carbon nanofiber. That is one continuous strand. Here is like what they wanted to make, they made it, and it's so easy that if you can read the paper, you can make it yourself also. So product is sorted. Now, the conference name was Scale. The idea is that there are a lot of startups. Startups have brain power. They do not have industrial horsepower where they can scale that puppy up. So idea was do that conference inside a bigger conference, bigger expo of CHEMTECH. So CHEMTECH has like a lot of industrial partners. So if you're like, hey, we need this furnace, CHEMTECH will have like at 1500 booths, half of them will be furnace only. So that was the idea, to help startups scale up. So what they need, if they can properly scale it up, they have IIT, basically Indian Institute of Technology, has monopolistic advantage, meaning if they can really mass produce it quickly enough, and the final product would be just a solar panel size thing. So backside would be insulation, front side would be a thin glass. Now why do you need glass? Well, to make sure the coating does not wash away with rain or dust and all that. It does not thermally affect it. It just needs to be there to safeguard. And again, cracked glass will only reduce efficiency because again now it will start to bounce back photons. The cracked glass will, the coating won't. So you have a basically same panel solar battery, but it does not require the air gap. Very small, very light, very effective, and it will have a smaller footprint, meaning how easily you can carry it, much better, cheaper. It's fundamentally not that complex system, and higher temperature. That is desirable. People do not like this flat panels one. They still prefer this vacuum tube one because this has, if I'm not mistaken, 10 degrees of temperature delta. So like of course you can reach very high, but there is a reason why this sells. So, and if, let this very clear, they have not reached that mass scale, so we do not know how the temperature works in loading. So if they crack 90 degrees Celsius hot water, this will make solar air conditioning viable in India. Why is that? Well, right now there are many places that do solar air conditioning, but people do not prefer it because it's too close to the margin. Like 80 degrees Celsius is very hard to do. It's not the heat. Think in this way, like we have the amps, we just don't have the voltage needed. So if you can crack that 90 degrees Celsius barrier, then you can run something like this. This is called absorption chiller. So there, if assuming you have a cooling tower in basically certain evening time, your cooling tower will receive a 33 degrees Celsius hot water. Hopefully your ambient is a bit lower than that, 21 degrees Celsius kind of ambient. Then the cooling water coming back would be 27 degrees Celsius. The hot water that you put into this is 90 degrees Celsius. The ejection would be around 83 degrees Celsius. And the chilled water, this is where it gets interesting, goes from 15 degrees Celsius to 10 degrees Celsius. That's full-fledged air conditioning. Now be mindful, the temperatures and variation, this company, the machine that they are selling, Bry Air, this can work at 50 degrees Celsius water, but be mindful, you must have hot water much hotter than the cooling water. The bigger the gap between the cooling water inlet and hot water inlet, the more COP you're gonna get, coefficient of performance. They can be very close, but the coefficient of performance would be very bad. That's why we need very high temperature on the solar collector side, because be mindful, where the heck you're gonna get cold air? India, hot air, sir. Our air could be around 51 degrees Celsius. So it's very difficult unless you do evaporative cooling. But again, that consumes too much water. So we do need this hot to be as hot as possible. Again, we have the amps. Sun has more than enough amps. We just need to increase the voltage. So this coating allows to break through that, ideally. Again, they were claiming they can touch 120 degrees Celsius. If at load they can reach it, then it's like, yeah, even at 51 degrees Celsius, we may be able to achieve 0.5 COP. So if you have a surface area that is collection of, let's say, 10 meters square, you're looking at 10 kilowatts. So you're looking at like around 5 kilowatt of cooling. That is significant. That is like shut up, take money territory. And be mindful, that it has the benefit. The sun, the time when the sun is going YOLO on your ass, the AC is like, I got you. So it's completely when you need it. It's not like, oh, in the night it's very cold. It's like already cold, man. It's like, first, and again, you have another benefit. If you have this sort of thing covering your rooftops, you don't even have sunlight directly falling, directly heating. So it's a very clever way of sorting air conditioning without poisoning the atmosphere and without creating a heat trap. This is like just solar heat is doing the main work. So if they can scale it up, they have genuine. If they can crack 90%, 90 degrees Celsius on load, this will start to make sense. Of course, I do not think you're going to get 27 degrees Celsius inlet water in India. Again, in many places you may get it, but not in India. So I do expect Indian COP to be much lower, but let's see how lower. Again, the company's claim is that it will work as low as 51 degrees Celsius hot water. Like 51 degrees Celsius, like I just put a glass of water in my rooftop, that's how hot it will get. So they do have advantage. Let's just very clear. If they start to deploy it on large scale and do not find random issues with it, it should be awesome. Now, what about cooling? I'm not talking about solar cooling. What about cooling using it? Now, you must have heard this statement that they couldn't see the forest for the trees. And this was my first time experiencing this. I feel so lucky, so privileged that it happened. It's like they were talking about like, I'm like, why are you not making this as a air condition? Right now, a lot of people are realizing that our air condition is very inefficient. Why? Because its coupling efficiency is not hot. This puppy, this body, is not that hot. It's barely 100 watts of energy. Unless you are doing humpy pumpy at very high speed, then maybe you are at 300 watts of heat. That's not that much. But you look at your air conditioner, that's like, bro, compressor warm up energy requirement is that. So why? Coupling efficiency is not good. So where are we wasting most of the energy? Well, moving boatload of air, cooling the air itself, basically nitrogen and oxygen and carbon dioxide in the air, and then water as in like humidity. Humidity is a pain in the ass, and because there is so much distance in coupling, you have to drop the air temperature way too much in the basically evaporator section for it to be like, to actually cool human body. So we have too much steps. So even though technically 500 watts of cooling power should be more than good enough, it rarely is good enough. So how can we solve this? Well, what do you have? You have a panel, a coating that can eat photons and not let it get out, especially infrared thermal photons. So radiative cooling is becoming a thing right now. People are trying this, and why people want to go with this? This can absorb photons right now without the coating. What if you have magic coating on it that allows even more photon absorption, meaning photons from your body, hot body that is dumping photons outwards, goes there, never comes back. Now, like, wouldn't the atmosphere block it? Our atmosphere is not a very active, IR active. That's why the army system worked. It's like, yeah, you could have the lamp. The lamp will not heat up the air. Wherever the photons are falling, those will heat up, but not the air, because air's nitrogen and oxygen, they are not very reactive to IR. Carbon dioxide is, but IR is, oxygen and nitrogen is not. But this way, you can bypass it. So this has significant advantage, meaning if they are, make a panel, let's say your air conditioner, I have an air conditioner here, it just becomes a big panel, let's say 2 meter square kind of panel, or maybe a bit bigger than that. I do expect it to be a bit bigger than that. And they are running chiller water on it. Now, of course, they do need to make sure the temperature of the water is above the dew point. So let's say dew point is 16 degrees Celsius, the chiller must maintain the water to be 17, 18 degrees Celsius. So all the photons that are bouncing on, that's what heat is, it was going to dump there. And because of the low, it's almost a check valve from a thermal energy point of view. So if photons can go in, it cannot come out. So it will start to become a perfect sink. And now because of the coupling efficiency, your body dumps the photons instead of bouncing around here and there, it's just like goes to one point, done. And again, there was another engineer there that were working with this sort of system. They said that people may not like a big black plaques. Well, it could be true unless we really show that there is significant enough advantage of doing this. People may be like, yeah, I don't want black plaques unless there is some artistry into it. But again, somebody else told me, what about theaters? They pay for black coating. Imagine their rooftops are just made out of this. So of course they would run a dehumidifier if needed. If let's say it's a weather, sawan weather, which is our rainy season, which can last for 1 month, yeah, you run dehumidifier then. But dehumidification becomes a choice for you. It's not like, oh, we are cooling the air, this is the byproduct. No, it's like, hey, do we need to deal with humidity? If yes, take care of it. If not, don't waste energy on it. So this has significant advantage if the IR spectrum window behaves as we are expecting. On the sun, we have tested it. Not we, as in like they have tested it, and research paper is available. You can look into it. So this would really be awesome because our body is glowing and this puppy can eat it up. Imagine a theater where rooftops is just like eating your photons away. Instead of cooling this whole volume of air, which unnecessarily gets cooled down, removing way too much moisture unnecessarily, is just like. So this has very significant advantage in absorbing heat from the places. It will not work with other things. That's the desirable part. Like your computer will remain the computer, but your body will remain cool because your body is glowing. So this is what we want. We do not want to go through the long route. We want to improve the coupling efficiency. This works amazingly well for that design. Again, we have to do more testing in the cooling front. Heating they are already doing. Cooling one, they need to work on it. But there is some serious potential here because we sell far more air condition than we sell solar water heater. So there is some serious potential here. So this was my presentation on basically NCF. Hopefully you guys have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me some disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.